Hello everyone, my name is Sally and today I'll be doing my research paper presentation based on the research paper Customer Rating Reactions Can Be Predicted Purely Using App Features. First of all, I want to give you a general outline of this paper. The authors of this paper present empirical evidence that an initial coarse-grained assessment of customers' likely reaction to a proposed set of features of existing apps. They established an attractive new predictive modeling mechanism to support app requirement elicitation. They organized this paper into 5 sections. After the introduction part, they describe the approach they used in this paper, and that includes 4 different phases. The first phase extracts raw data from 2 different app stores, which are BlackBerry App Stores and Samsung App Store. In the second phase, the raw data is parsed to retrieve all the available attributes of each app relating to price, rank of downloads, and textual description. The third phase used a method called NLP in terms of natural language processing to extract the feature of apps from their textual descriptions. Then the fourth phase used CBR in terms of case-based reasoning to retrieve the K most similar apps from this database. In the third and fourth section, they talked about the design and result of this study, from the aspect of predictability across categories, and actionability. And finally, they discussed the more related work and future study in section 5. So, why do this research? I've listed 3 reasons as I find in this paper. The first one is the competitive market. According to the scientific data, more than 60% apps in Apple Store has never been downloaded in 2012. 80% of paid Android apps received fewer than 100 downloads in 2011, and 80% of apps were abandoned after 90 days of use in 2017. The second reason is that correct predictions of the rating of apps could also help developers to better understand users' requirement to avoid unnecessary effort and time to put in. And the third reason is that past research has shown that rating and downloads are often highly correlated, and rating is one of the key determinants of users' app purchase decisions. These results could help developers to use claimed features of existing apps as a form of requirement elicitation for new proposed apps. Here I want to talk about the methodologies used in this paper. First of them is called natural language processing. The authors used this in the third phase of section 2 to extract the features of apps from their textual descriptions. They've also used a 4-step NLP algorithm called Natural Language Toolkit to extract features of apps written in natural language. The general approach in this paper is to form a vector of values that consist of a numerical value representing the rating and a bit string containing 1 bit per feature that a mobile app may process. It will show 1 if the app processed the feature and 0 if not. In this paper, they also used a method called case-based reasoning to retrieve the K most similar apps from database. Let's say given a target app, CBR identified similar apps by using a similarity function that measures the distance between the target case and the other case based on the value of the n features of these apps. They've also used a method called n-dimensional Euclidean distance to measure the similarity. So once the K most relevant cases have been retrieved, they use weight mean to obtain the final estimate for the target app. Here I wanted to talk about the novelties in this research paper. First of all, as a reader, I really like the way they address their design process and result of their study. They used Q&A methods in section 3 and 4. They brought up problem-related questions in section 3 and answered them in section 4 respectively. For example, in section 3, they asked a few questions, such as, can we predict the app's rating from their claimed features? Does rating predictability vary across app stores categories? And how robust is their approach to the choice of the number of K used to form the cases for predictive modeling? In order to answer these questions, they compared the prediction accuracy achieved by CBR with random guessing results, and also analyzed them from the aspect of data evaluation criteria, case-based reasoning setting, and threats to validity. The second novelty in their paper that catch my eyes is that they used a lot of figures and charts and scientific data to show us the results. For example, the CBR achieved an absolute residual error ranging from 0 to 5, and 75% and 81% of the apps they tested result in an absolute residue of 0, which stands for a highly accuracy, which also means that apps rating is predictable. They also compared their prediction to random predictions to justify whether their results were just due to pure chance. And this is illustrated in Figure 3. From the chart, we can see that the absolute residue errors provided by CBR are on average lower than 0.5 and are much lower than these provided by random guessing for both stores. Thus, it confirms that the absolute residual errors provided by CBR are significantly lower than those achieved by random guessing, with large effect size for both stores in 100% of the cases. The result of their second question is shown in Figure 4. In this chart, we can see the mean of absolute residue errors obtained by CBR and other data for each of the categories of two stores. We can see that CBR achieved the lowest MAR error for all the BlackBerry and Samsung categories, indicating that it provided more accurate estimations with respect to random guessing for both stores. This answered question 2, that apps rating is predictable across categories of both app stores in 98% of the cases. They've also used a table of data to answer the third question, which is illustrated in Table 5. It reports the result in terms of mean absolute residual errors obtained with CBR using 1 to 15 analogies and denoted as CBR1 to CBR15. From this table, we can observe a very low variation in the form of MAR1 to MAR15. That is to say, there is a very low standard deviation. As we can see in this table, that 19 categories has less than 0.1 standard deviation, 5 categories less than 0.2, and only 1 category is around 1. Thus, for the answer of question 3, the approach is robust to different CBR configurations. So all the answers to the questions in section 3 are answered in section 4 respectively too. So after proved their results in section 4, they introduced us more related works. The first one is about the investigation of prediction models based on information extracted from requirement specification documents. Their results suggest that the measures from the artifact produced during the requirements phase are not worse predictors than those based on code source measures. The second one is that Xia used machine learning to predict crushing releases and revealed that they can improve over a baseline predictor by 50% and 28% in terms of F1 and AUC respectively. Finally, several analytic companies provide usage data to developers, such as downloads, in-app purchase info, to make data-driven decisions that may allow for more successful apps. However, these recommendations are mainly proposed from a marketing perspective rather than a software engineering one. So all of these previous work, none has provided assistance to app developers in determining arguably the most critical aspect, which is the app's requirement. However, this research paper indicates that it could fill this gap using the features previously highly related by users, thus further prove the importance of this research. At last, I want to discuss some future work and improvement could be made to better this research. In my opinion, future investigation of predictive models of customer evaluation could give this research a bigger coverage and could provide more valuable information to developers. Also, the data availability in the App Store could be improved too. As the authors mentioned earlier, one problem about data availability is that the majority of the current app stores only provide information about the highest performing apps, and that could lead to an inaccurate research result. If the data availability could be more accessible and has more coverage, it could make the prediction more accurate and help developers to better understand users' requirements and make better products that fit the market. So the above are all my thoughts and understanding from this research paper, and this will be the end of my presentation. Thank you.